Good afternoon, pre-algebra students. This is Mr. Wirtz. I am in a meeting today, so you are going to get a series of videos that I want you to watch, and this is the first one. Before we get to section 6, we're going to go over a couple of problems, a couple of questions from previous sections that people have asked me about. Here's the first one. A couple of people have commented on they didn't understand how to do this one. And so this is from section 4, the complex numbers section. It says to find real numbers x and y that make the equation true. 5 plus y of I equals x plus 3 of I. Now you may get a slightly different version of this question, but the same basic idea on this. And so you need to figure out the values of x and y. All right, and you may wonder what is, how to do that. Well, there's one rule of equality of complex numbers that we talked about in that section, and that is if we have two complex numbers, a plus bi equals the complex number c plus di, then the real components, the a and the c in this case, those two have to be equal. And the imaginary components, the bi and the di, have to be equal as well. So the value of b will equal the value of d. So when we take a look at 5 plus y times I equaling x plus 3i, then we can see that from that, if we take a look at the real components, that would be this and this. And so then we could say 5 equals x. Okay, so the value of x equals 5. The imaginary components are going to be the yi and the 3i. Since they both have an I in there, we can ignore that. We can just say y equals 3. So the two values of x and y are going to be x equals 5 and y equals 3. Why? Because there is an equality of complex numbers rule that we use for that. And that's the reason why it's true. So you can write. This is one of those answers where you kind of have to write out the answer instead of choosing a multiple choice. So just kind of do that to your best of your ability. You don't have to write a long essay or anything like that. Just give us that reason from the section, and that's the reason. Okay. Okay, from section 5, 2.05, under the section for fundamental theorem of algebra, we just finished this one on Tuesday. The last question on that had looked something like this. Again, you may get a slightly different version of this question, but the idea is going to be pretty much the same. This is one that looks like it's going to be pretty challenging, but in reality, it's actually not. And I'll tell you why in a second. It says, using the given 0, find one other 0 of f of x. Explain the process you use to find your solution. All right. Well, we have one solution. 1 minus 6i is a 0 of f of x equals x to the 4th minus 2x to the 3rd plus 38x squared minus 2x plus 37. And so you might be thinking, well, boy, I'm going to have to see if I can find a 0 by using synthetic division. And boy, we can use positive negative 1, or we could use positive negative 37. Well, actually, you don't have to do any of that stuff, because remember the basic rule. Okay? If you have 1 complex 0, a plus bi, for example, then its conjugate is also a 0. So if a plus bi is a 0 or a root of a polynomial, then its conjugate also is. So if a plus bi is a 0, then a minus bi is also a 0. So in this case, if we have the conjugate, I'm going to abbreviate that if you don't mind, of 1 minus 6i is going to be 1 plus 6i. Okay? If 1 minus 6i is a 0 of f of x, then 1 plus 6i is also a 0 of f of x. That's it. That's all you need for that one, because it's a conjugate. Now you could do a synthetic division. You could see if you can see if 1 is a 0 by using synthetic division and seeing if you get a remainder of 0, or you could try 37 or positive negative 1 or 37. But you don't really need to. That's all you need to do is this. Okay? And that's how you do it. So make sure that you answer that question, and look forward to seeing your results on those assessments. If we have any questions on any of those others, I will answer those when I get back on, let's see, what is it? Thursday. All right. All right. Our next recording is going to be is going to cover section 6 on rational functions.